Hello. Yeah. Okay, everyone. Hello, welcome to week 3. How's everyone going with the course? Yeah, yep. I see. Sorry? Very hard. Very hard. Okay, so, and I'm sure lots of people are thinking that same thing. So last week, we threw a lot of stuff at you. Maybe this is a bit loud. Hang on. Okay. We threw a lot of stuff at you last week. We looked at if statements. We looked at scanf returning a value so we can error check. We looked at while loops. We looked at nested while loops. We looked at structs. We looked at enums. So that's a very long list of things. So don't feel too overwhelmed if you don't feel like you're on top of all these things. We threw a whole lot of things at you at once, and you've seen it for the first time. We're going to do some recaps today, And you're also going to be going over all of these things in tutorials, and then you're going to be coding these things yourself in the lab. And it's when you're doing that that you'll really get on top of what you're doing, right? You have to, it takes a few attempts to, you know, learn these things. You don't just get it all straight away. So if you're thinking these nested while loops seem tricky, yeah, they really are. The first time you see them, they're very tricky. And it's going to take some practice before you feel like you're on top of them. But all of these things that we're doing now, we'll be using throughout the whole term. So you've got, like, you'll have weeks to really get completely on top of these topics. Okay, so don't panic now if you think, oh, I don't understand this, this, and this. You're going to get there. So, all right. Now this is the first time you've got a lab that's been due that's worth marks, right? So lab 2 is due tonight at 6 p.m. How have you gone with lab 2? Okay, I can see some nodding. Now, don't forget you do have to submit it using Give. And if you're still working on some of the exercises, submit the ones you've done, and you can even submit late for a small penalty. So when it reaches, ideally, don't submit it late, but just say for whatever reason you're still working on it, you can submit it up to 5 days late with a penalty. It's about equivalent to 5% a day, but we do it by the hour. So I'll let you do the maths of how much it is per hour. But that's how much you'd lose for it being an hour late, right? So worst case scenario, if that happens, don't just give up on the lab, keep working on it. Now this week we've got help sessions. So these are those optional drop-in sessions that you can go to just get help from a tutor. So you probably saw a forum post, but I'll go and open this link, I think. Yeah, here's the link. This shows the timetable, and also, even if you don't have the link, you can go to the course website and see the timetable from here. So this is the week 3 help session schedule, and we can see that even tonight there's one on. So you can go to a help session online tonight from, I think that's meant to be 6 till 8 o'clock, between 6 and 8 o'clock. And get help from Sophia, who's one of our amazing tutors and admins. Okay, and you can ask questions about lecture content, tutorial content, lab content. All right, if you're going to do that, click on this link to get more information. There's a link here. All right, any questions about that? Oops. And here's a link from these slides as well, and there's a Teams code that you might need to join. Oh, the other thing is there are some face-to-face ones, there are online ones. When you go to the face-to-face one, they're not in our computer labs this term, so please bring your own device. Okay. All right, another admin-y type thing. Next week on Monday, we've got a public holiday. So we'll have a pre-recorded lecture that I'll upload either before Monday or on Monday. And please make sure you watch that, because that's going to have core content in it that you need to know. And if you don't watch it, if you go to watch the lecture after it, you know, it might not make sense because it will follow on. Now, hands up if you're a student that's in a Monday tut lab. Oh, wow, a lot. Oh, you're all going to come today in person, right? Yeah, your tutorial and lab won't be running next week because of the public holiday. We don't want you to miss out, though, on a tutorial and lab, because we think they're the most important part of the course, or one of them, like going to those labs and working through those problems. So here's a link. And again, this will be probably on the forum as well at some point. This is a link. If you're a Monday Tut Lab student, you can go get a ticket to attend another time slot in the week. And this is just so we don't want everyone turning up to the same time slot and having too many people, right? So book in now if you're a Monday Tut Lab student, so you don't miss out on your lab next week. Any questions about that? All right. Also, because of the public holiday, you'll have an extra day to do lab 3. It'll be due on the Tuesday instead of the Monday. Okay, but that's just for this week with a public holiday. We'll go back to our normal schedule. All right. So, today we will do a bit of a recap on nested while loops, just a quick one. Then we'll do a recap on structs and enums. And then we'll do it. Then we'll do an example of having enums in our structs. Then we'll talk about functions and style. So yeah, most people are finding it's starting to get hard this week. And the thing is, just keep practicing. Don't avoid it if it's hard. It'll get easier if you practice it. It won't get easier if you avoid it. And that's something I have to remind myself about all the time. Oops. Lecture code. There's always a link to the live lecture code that you can look at during the lecture and or after. If there's anything missing that you think I haven't released, please let us know either on the YouTube chat during the lecture or after or whatever on the forum. Okay, let's get started on some actual content. Oh, I've given away the answer. I was going to say, what does this code do? So this isn't a nested loop. This is just a loop, a while loop. And what this is doing, basically, I'll run it. I've already kind of shown you with a comment. This is just printing out all the numbers from 0 up to but less than 5, right? I should show you that the size is 5. So it's to less than 5. So our counter will start at 0, and 0 is less than 5. So it's going to print out a 0 and a new line. But then we're going to increment that counter, and it's going to now be 1. So we're going to print out 1 and a new line. Then we're going to increment it again, and we're going to get 2, etc. Eventually, when we increment it, row will be equal to 5, and the loop will stop. All right, any questions about that? Okay, so now let's see if we can modify the code we've got. How do I get rid of that now? How do I get rid of that? I'll move it over here. So I don't have to look around. Okay, now if we want to modify our code to get this kind of pattern, what should we do? So before we had a while loop, and it was printing out something and then going to the next line, printing out something, going to the next line, printing out something. And it was doing that 5 times. But now, on every row, we don't want it to just print one number. We want it to print that same number, but many times. Yep. You have to nest another while loop for the columns? Yep, exactly. We're going to nest another while loop, so we get 5 columns. Perfect. So we can give chocolates out too. Throw some chocolates around. Okay. So yeah, and I'm going to have some counter for this inner loop. And I'm going to go... Actually, that was very good. I don't know about that. Compared to if I threw it. Okay. So we've got this inner loop. So now the inner loop, every time we go to each row, this inner loop is going to run, well, how many times is it going to run now? This inner loop. Can anyone see what I've done wrong? Infinitely, because I forgot to increment my counter. Okay, now this inner loop is going to run 5 times itself, but every single time it's just going to print out the same thing, whatever the value in the row is. So let's just run it, and then I'll sort of go through it a little bit. Oh, now what have I done wrong now? Yeah, we don't want a new line after we print every single number. So if I get rid of it, that's still not right. When do I want the new line? Yeah, when I've done this particular loop is printing out the same number 5 times, and it's after that loop that I want a new line. Oops. Okay. And actually, I do want a space after this. There we go. Yeah, that looks right. Now, what you can do, a good thing to do is maybe change the size of this to 3 so it's smaller, but you can trace through it. You can think, well, row is equal to 0. Then I get to this line here. Is row equals 0, is that less than 5? Yes. Now I get to this line, col is equal to 0. That says row, by the way. Col is equal to 0. Is col less than 5? Yes. Now we're in here and we're printing out the value of row, which is 0. And that's printing out like this first 0. But now we're incrementing col to 1. Right? And because it's a while loop, it's going to go back to here and check col again. Is it less than 5? Yes. We print the value of row again. We increment col, and this will keep going until col gets to 0, 1, 2, 3, 4. When we get to 5, col is 5. That's not less than 5. This inner loop stops. Now, what happens when this inner loop stops? It just continues after the inner loop, right? The inner loop's finished. We continue on. We print the new line character. And now we increment our row to row equals row plus 1. And now our row is 1. Oops. So you can trace through things like this a bit more carefully than I just did it to get an idea of how things are working and how the execution's going. Now, eventually, row will be equal to 5 if we keep going through again and again and again, and the outer loop will stop as well. All right. Any questions about that? All right. Is that clear? Completely confusing? A bit of both? So actually, do we want to trace through it again with a size 3? So it's easier? Yeah, let's do it. Okay, this is easier to trace through. So we start here, the first line, and row is equal to 0. And we check, is 0 less than, in this case, 3? Yes. So we go inside this loop. Now we've got another variable called col, and we're setting that to 0, and we're checking, is col less than 3? Yes. So now we're inside this inner loop. I'm not usually that rude when my phone rings, but this isn't my phone. Okay, we're printing out the value of row. The value in row is 0. So this is giving us this first thing that's printing out now, like here. Now we're incrementing col, and col is, when we say incrementing, it means we're adding 1. we're at the end of this inner while loop. So it's a loop and it goes back to the top. So this little inner loop will keep going until it finishes. Did I forget to increase? No, I didn't. All right. Next time round, 1 is less than 3. We still are printing out the value that's in the row variable. So we get this 0 here. And now we're incrementing our col to 2. We go back through the loop, check again, is 2 less than 3? Yes, it is. It prints out this 0, and we increment our counter again. Now this time round, when we go back, we check this condition again. 3 is not less than size. So this while loop, the inner one, has finished its job. So it stops, it just stops and it jumps down to the end of this while loop. So when a while loop finishes, it will start executing after that close bracket. Is everyone sort of happy up to here? All right, and now at this stage, we get that new line character. We're printing that, and now we're incrementing row. So now row is going to be equal to 1, and now we do this whole thing again. Well, not all of it. We jump back to the beginning of the while loop. Is 1 less than 3? Yes. So now we go in here again. And this next line is really crucial to make it all work. We need to reset this counter for the inner loop back to 0. And then it's going to start again, right? It's going to go through col is equal to 0, and it's going to print out the value of row, which is 1. It's going to keep going around in this while loop until it's printed out that 3 times. It'll stop again when col is equal to 3. That while loop will end. And it'll continue executing down here, which will print out this new line, increment row, and go up there again for a whole nother cycle of all of that again. Okay? And it'll do this until row equals 3. So it's going to reset col, go through, print out this whole row again, and go back to the start. Okay. So any questions about that? Hopefully that sort of makes some sense. Now, and you'll practice lots of these this week in the lab, I believe. Now, I'll leave this as a little challenge. Oh no, let's just do it. How could we modify this? And I'm going to put the size back to 5. So, but this is just a tip too. If you're trying to understand something, try and make it as small as you can make it, so you're not thinking about, you know, like a 1,000 by 1,000 grid. You know, look at a 3 by 3 grid. So, I can't. Do you want to do it in the, oh yeah, in the break, unplug it. Okay, so this is what we've got so far. Now, in this situation here, what's the difference between this output that we want and the output that we've got so far? So it's kind of the same, except in some places, instead of the number being there, it's just a space. Oops. Right? But it's the same pattern, just in some spots, there's not the number, there's a space. So what we can do is we can have some kind of condition saying, well, if, and we need to work out what that condition is. In this case, I do want to print out my row variable. But otherwise, I don't. I just want to print out 2 spaces. instead. Now we've just got to work out, well, when do we want to print out the row variable? And then everything else, we're just printing out 2 spaces. So just think of some situations where we know we always want to print out the actual number. Like just look at the pattern and use English words or whatever. Yeah?
If it's 0 or 4, we always print it.
Yeah, if it's 0 or 4, so if it's the first row or the last row, we're definitely going to print it. So to write that in code, we could say, well, if row equals 0, that takes care of that top one. Row equals 4. How do we join these things together though? So yeah, we could do separate ifs. If it's row equals 0, print the number, else if it's row equals 4, print the number. Or we could join it together. Now, if we do ands, a variable called row can't store a 0 and a 4 at the same time. So this is not the right condition. It should be or. So if the row is equal to 0 or it's equal to 4, we'll print the number. Now this obviously isn't 100% yet. There are some other times we want to print our numbers. When else do we want to print these numbers? What's the other pattern we can see? Yeah? Yeah, it's like every second column. Now, what is the value of our column counter when we're printing out these columns? So column starts at 0, like the variable col, goes from 0 to 1 to 2 to 3 to 4. So what do the values of col have in common when we want to print out the numbers? Yep.
When the modulus of the col number is 0, you can print the row number.
Yeah, so we're basically printing every second column, and the way we've numbered our columns are 0, 1, 2, 3, 4. They're all the even columns. So if we've got a counter called col and we do mod 2, that's asking us for the remainder when we divide by 2. Then if that's equal to 0, it's an even column, and that's when we want to print the numbers. Now there's all sorts of different ways you might do this, right? This is not the only answer, but it just shows you how you can have nested while loops and then if statements inside them to control exactly what's going on. All right. So yeah, this was a bit of a trickier one, but you'll get used to doing things like this and thinking like this. Okay. All right. So hopefully when you go to the lab this week and you see all these loop questions, you'll be ready to really tackle them. Let's now give ourselves a few seconds to clear our heads and we'll talk about structs. Oops. All right. So hopefully you'll at least vaguely remember we talked about structs. Now, a struct allows us to create our own custom data types. So there's nothing inbuilt in the C language that helps me represent data about a student. I've decided I need to represent data about a student. I'm going to create or design a struct student. I'm going to decide what data that I need my struct students to have in my program. And I've decided, because we don't know how to do words yet, I've decided a first initial, a last initial, an age, and a lab mark. But it's whatever you want in your application that you're doing. Oh my goodness, what if I do that? Okay. So this is just the design of the custom type. Now, once we've done that, this allows us to create variables of this type. So down here, we're saying I'm creating a variable called Ryan of type struct student. That's now a type we can use in our program. When we do that, we get a chunk of memory big enough to store 2 chars, an int and a double, all in one package. And to access those individual, we call these members, to access these individual members, we use this dot. So I can say Ryan dot first initial equals R, and that can go and set that data inside that variable. I can say Ryan dot last initial equals Z, Ryan dot lab mark equals 4.4, Ryan dot age equals 30. Do you want to come and do it? Yeah. pull the plug on this terrible phone. Sorry, guys. Okay. Now, if we want to modify the data in one of these fields, we can. I'll just wait a second. Thank you. Everybody, thank Liam. I was about to call you Ryan from the example. You can have some chocolates as well. If it rings now, we'll really be like in trouble, right? Okay. Now, if I say Ryan.age, that's referring to an integer, right? So I can do anything that I might do with an integer. So I can do something like Ryan.age equals Ryan.age plus 1. Okay. Okay. And in my diagram, I drew these around in the wrong order. Okay, the age would be next. Anyway. Down here, I'm going to print it out. Again, C doesn't know that I was going to invent this struct student. There's no percentage thing that can help me print it out as one whole struct. I've got to go and print out all the individual pieces, the two chars, the int, and the double. And I have to use the dot to get all those individual pieces out. Now, I could use scanf as normal. Like just say Ryan complained and said, actually, I got 10 out of 10 for that lab, and we need to go change it. We could do a scanf, and again, Ryan.labmark is of type double. So we can just do a scanf like we would for any double and say Ryan.labmark, and of course, because we're doing scanf, put the ampersand. So I could run this. Compile it. And type in something different for that lab mark. I'll say, no, you got 9.5, whatever. And that's going to go, I've made a mess. It's going to go and modify this field. Okay. So these are the basics of structs. We haven't really shown you how useful they are yet, because I know for a lot of people you'll be thinking, how on earth is this any more useful than just having all the separate variables? But we'll see later today, once we use functions, how we're able to pass these things around like a little package with all the data in one sort of thing, right? It's like having a box with things in it rather than having all those separate things lying around. So it will help us, we'll see. Okay, we also looked at something called enums, and I think a lot of people were confused about these. Now, enums are just another sort of fancy way of doing hash defines for integer constants. So if you've got a set of related constants, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, they're all related. They're all days of a week. You could type it in like this instead. And C would be just as happy. You'd still be able to get it to work. But for humans, this is a lot nicer way to do it for a number of reasons. You're not typing in hash define again and again. You're not accidentally going to give these the wrong values and give two things the same, or skip a number or do something silly, less error prone. But it's also very clear that, if I've got a variable of this type, so I'm doing two things here when I do this weekdays enum. I'm creating a set of constants, mon, tu, wed, third, fry, sat, sun, with the values 0, 1, 2, 3, 4, etc. But I'm also creating or defining a type. So now I'm able to create variables of this type that can store these particular values. So these are the only different types of values we should be putting in this variable. And what it does for us is the C compiler will know if I say enum weekdays day equals March, it's going to say no, that's the wrong type. If we've just got hash defines for everything, the compiler isn't going to know the difference between Monday and January, right? Or maximum students or any other constant you've got. And this makes it very clear to the users that, Monday is quite obvious, the days of the week are obvious, but it makes it clear to the users what the valid values are for these different types, rather than just having all these hash defines and you don't really know maybe when you should be using them. Okay. Is everyone sort of clear why we might use these? Now, when we print this out, I've said, oh no, we can't do this. That's an example of what you can't do. Let's make it Wednesday. What's this going to print out? Does everyone remember? Or does anyone remember? Yeah, it's just going to print out the numeric constant. So we write wed, it's writing 0, 1, it's storing a 2. I've created a variable called day and it's storing the number 2 on the computer. And that's great. The computer loves numbers like 2. For a human though, if we just typed in 2, we don't necessarily know what that means. Even if we know it's a day, like does 2 mean, is Sunday 1 and Monday's 2? Or it's confusing. Wed is much clearer. But when we print it out, we assume a human's reading the printout. We don't want to see 2. Now, with the sort of stuff we know, the only real way that we could get around this is to do an if statement. And I've done one earlier so I don't have to type slowly and take the whole lecture doing it. But you'd need to do something like this. Every time you wanted to print out one of these enums, you'd need to do this code. And if you had another variable, you'd need to copy and paste this and change it so it's printing out the other variable. Right? And this can get repetitive if you're doing this all the time. But we'll see again later today when we do functions, how we can package these things up and only write them once and then reuse that code again and again. All right, any questions about structs or enums? Because we're about to combine them. Okay, so the other day we made an enum for a Pokemon type and I added normal to it. Anyway, and it's quite wide. Now we'll talk about the style guide later today, hopefully if we've got time, but we've got a style guide and it tells us we shouldn't go over 80 characters wide. And if you've got your CS1511 set up, you'll have this line like I do. Does everyone have this line? And it's showing you where that mark is. So this is too wide. So I've re-spaced it like this. Anyway, it's going to do the same thing. The computer doesn't care, but the style guide would prefer we didn't make our lines really wide. All right, so I've got my Pokemon type, but what we want to do now is create a struct Pokemon. And what are some things a struct Pokemon might have?
Name.
Oh, we can't do a name. Yeah? Health points. Oops. What else? We're not going to get everything down here 100% accurate for your Pokemons. Yeah? Level? Anything else? Is there something we could use a double for, just for the sake of it? Defense? Right. And there's probably attack and all sorts of things. And what else could we put in here? A type. So I could have an enum Pokemon type. And I could have, I'm going to do primary type and secondary type. Again, this might not be 100% true to Pokemons or this stuff, but all right. So now I could define that this is what my Pokemon struct is. So now I could create variables of type struct Pokemon. Okay, I'm just calling it this one Jigglypuff. And I can go set these values. Now again, these might not be valid values that I'm setting for Pokemon, but that's all good. Health points, 110, level equals 1. And now I'm going to give Jigglypuff 2 types, like Pokemon types. I think this might be correct, but again, please let me know if it's something I can easily change if you're deeply upset because you love Pokemons. Now, once we've done all that, we've got a Pokemon variable that I've initialized with all of this data. I'll just write fairy and normal because I've forgotten the underlying constant values, which I should. We shouldn't be thinking about those. Now again, how would I print all this out? What I'd have to do is I would have to do a printf that prints out the health points, like printf%d to print out the health points. A printf%d to print out the level, a printf%lf to print out the defense. And then I would have to do some kind of if statements that goes through all of these different options to print out the primary type. I'd have to do that again to print out the secondary type. Okay, I've done it already. Well, I haven't done it exactly like this though. I'm going to copy and paste it so it doesn't take too long. So we've got health points. Health points. Level. Defense, and then the primary type, I've got all these if statements. The secondary type, I've got all these if statements. Okay, don't worry, you don't have to look at every line, but we want to see that actually this is quite long and annoying to write. And this is what we call like code duplication, where I've copied and pasted basically this whole thing appears twice. The only difference is once I was trying to print out the primary type and once I was trying to print out the secondary type. So this is the kind of thing we want to avoid in our code. And today, we probably need a break soon. Today when we get to do functions, we'll see how we could put this in a function so we don't have to keep copying and pasting. Like imagine if we now had another Pokemon and we wanted to print out its types and we copy and paste this another 2 times, you know, it will become a nightmare. So when we see functions, we'll be able to do a little better than this. So all that code to just print out these lines. Anyway, any questions about that? About why we might use structs or enums or any of the syntax, like the dots are okay. Okay, so we'll come back to this. You're not supposed to have read every line. I haven't given you the chance, but I want you to see that it's long and that's, you know, copied and pasted a lot. Done that. All right, so we'll go to a break in about 5 minutes, but what does everyone think of when we say the word function? What's a function? So someone said an equation that gives an input and an output. And that can be true in computing as well. We have functions, we give them inputs, they give us outputs. And that's definitely what you're probably all thinking because we've all done years of maths and you're probably thinking you might even graph it or something. And that's true, we can do all that stuff as well. But in computing, the focus on functions is really the fact that we can make it an independent, reusable block of code and that it's going to perform a specific task. So the whole benefit of functions in computing is we write that code once, and yeah, maybe it's a square root function that takes an input and gives an output. We write it once and then we just use that function all the time. Or maybe it's a printf function that someone else wrote that we just use all the time. So we don't have to rewrite that code ourselves. But yeah, so that's what we're looking, that's how we're thinking of it in this course. But definitely inputs and outputs is an important part. Have we seen functions before in this course? Yep. What are the examples of functions we've seen or written or used? Yeah, we've been writing main functions, right? But we can write more functions. Our code doesn't just have to have the main function. We can write other functions that we can then use in our main function and break down our program into like smaller parts. What are the other functions that we've used? Yeah, printf, scanf, and they're from the stdio.h library. That's why we always hash include stdio.h. And there are lots more libraries and lots more library functions that we will see later in the course. But to get started today, we're going to write some of our own functions. Okay. Yeah, let's have a break now. And we'll come back at about 2 past, a 10-minute break. Okay. Okay, are we on? Oh, we're back. Okay, so we're going to get right into functions. First of all, let's talk about using functions, right? So we've used scanf and printf. And how many of you have ever gone and looked at the code, the library code for scanf or printf? Yeah, no one. I think no one. Because you don't need to know what that code looks like to use the function. And that's one of the great things about functions. They provide abstraction. You don't have to know the details about how printf or scanf were written. And actually, they're really tricky. That's really tricky code. I don't recommend you go have a look right now. But what you need to know to use a function is what the function does, right? I'll just wait. Oh, people are coming back. I'll just wait a second. Okay. Yeah, to use the function, you need to know what it does, because that's why you're using it. And you need to know how to use it. So you need to make sure you're passing in the correct sequence of inputs. So if you're doing a printf, you need to pass in something in quotes that tells printf what you want it to print, and maybe some variables. And all of these things have to be the correct types and in the correct order. Okay, and we call these things arguments. It's the data you're giving printf so it knows what to print, or the data you're giving scanf so it knows what to do and read in. Sometimes our function also has a return value. So scanf reads in data, but it also returns the number of things it read in successfully. It says it does what you asked it to do, but then returns like 0 or 1 or 2 or whatever to say, yep, I read in those 2 integers. And then we call this a return value. We can store it or use it, or like with scanf, we did ignore it for quite like the first couple of weeks. All right. Now, whether you're writing a function yourself or using a function from a library, one really important thing is a function prototype. So with a function prototype, here's an example of one, and this is a function we are going to write today. We give it a name, so once we start writing functions, we've got to start thinking of nice function names, right? So this function is called maximum. We wouldn't want to call it M or something that's cryptic, right? We want to give it a good name. So that's the function name. Then we've got the arguments. The arguments basically tell whoever's using this function what inputs this function needs. So this function needs 2 integer inputs. So if you want to use this, you've got to give it 2 integer inputs. Then it's giving a return type. So you put in 2 integers and you get 1 integer back as your answer. Okay, this is what this prototype is telling us. Now, if it was a library or something, there'd probably be a comment telling us that this finds the maximum of the 2 integers x and y or something like that. But you now know how to use it in the program. Well, I'll show you how you'd use it. But even without writing any code, does anyone want to volunteer to be our maximum function? All you need to, yeah, okay, we've got a volunteer. What's your name? Sonakshi. Sorry if I've said that wrong. Thank you for being well, right now your name is Maximum, and your job in life is, if I ask you to find the maximum of the 2 numbers and tell me the answer. So I'll say maximum 10 and 7. Yep, and the maximum function has returned the answer of 10 to me. If I say maximum minus 3 and 1,000, 1,000. So we've got the input and the output. Okay, so that's what a function is going to, this function is going to do. Thank you, thank you, thank you. Please get chocolates or Skittles. Now, that was calling a function in real life. How do we call a function in our program? Well, and we are going to write the code for this function as well. But I've got my prototype up here. And down here in the code, this is my function call. So the function call is when you're writing the name of the function and saying, please go and execute this function. So we're asking them at the maximum to enter, and we're passing in 2 integers. The first integer we're passing into this is just the value 10. The second integer that we pass in is going to have the value what? 7. So we're really just, this is just like me saying what's the maximum of 10 and 7. Now, if this maximum function works properly, it's going to return the value 10, and we're going to store that in our variable. This is how it should all work. Does that make sense? And then, you know, I can go print it out, or I could use that in another calculation or do whatever I want. So this is how we would use a function like this. How would we actually write the function? Well, this is what my function would look like, the actual implementation. Now, I've got basically the same as the prototype up here, but instead of having my semicolon, I've got this open and close bracket. Everything inside here is my implementation. Now, you might have your own way of finding the maximum of 2 numbers. That's not really important, but the important thing is I've got code in here that somehow determines the maximum of these 2 numbers, and we've got this key statement here that returns it. So I might go down to my code and run it and talk through it from there. Okay. I've actually added extra code to this version. So let's just talk through what's happening here and what's being executed. I've got my prototype up the top. This is just to let the compiler know that there's a function called maximum that exists, and these are the inputs and this is the output. So then it knows when I'm using it in my function that, you know, it's not a compiler error or anything like that. It's legal. Now our program always starts executing from the main. So it's going to start here, and we're going to have a variable called num that's equal to 7. And I've got a variable called max, and it doesn't have a value yet. But on this line, I'm doing my function call, and it's going to pass in the value of 10 and 7 into this function. And the execution is then going to, we're going to stop executing in the main for a while and jump down into this maximum code. So we've passed in the values 10 and 7. So this maximum function will have these parameters, we call them, x, that will have the value 10 in it, and y that has the value 7 in it. Okay? So it's just passed in order. The first number that this function gets, it's going to call x, and the second number it's going to call y. And then this function has its own variable called max, right? These are 2 separate variables in different functions. They've got the same name. I mean, there might be 2 people called Max in this room. Is anyone called Max in this room? Anyway, but there could be more than one of you, right? But you're not the same person. These aren't the same variables. Now, in here, we're just executing this code. You might write your if-else statements differently and, you know, different order. But we're just checking, you know, is x greater than y? Well, if it is, that's the maximum. And in this case, that's what we do. Then at the end, we return this value. So what we're really doing is we're returning the value 10. And when this function finishes, all the memory that was used for these variables can sort of be wiped. It's done its job and it's returned the value 10. And in this particular program, we're storing that value 10 in this variable here called max. That's sort of actually what's happening. So the short story is we pass in 10 and 7 and we get back a 10. The long story is the one I just told you. But does that make sense? Okay. And then we're just printing out the maximum value is 10. Now, we can keep going. I've got more code here. I've now got two integers, n1 and n2. The user's going to type those in. So maybe the user types in -3, 1,000, whatever. When we execute this line, we're calling the function here. Now this function is going to return an integer, right? So we can use this function anywhere where you could put an integer. We haven't even stored the return in a variable anywhere. We just know that this is going to return some integer and we're going to print it out. We can plug it straight into printf like this. We can put it anywhere where you would put an integer because it returns an integer. So when we get to this point, we're calling maximum function again. This time we're passing in -3 and 1,000, assuming that's what the user typed in to scanf. So the x in here will be -3, the y will be 1,000. It's got its own max variable and it does this and it works out, well, x is not greater than y, so the max is equal to 1,000. It returns that max value. So basically, this printf statement is going to say the maximum of -3 and 1,000 is 1,000. That value that got returned will be printed out straight away. Does that make sense? So you could do it like this. You could create another variable or something and say max2 equals maximum of n1 and n2. And then print out that variable. Okay, does that make sense? I'm going to call my maximum function. Actually, let's run it. I'm going to call my maximum function. It's already worked out that the maximum of 10 and 7 is 10. Fantastic, it's printed that. We're up to here. I'm entering two ints. I'm going to enter -3 and 1,000. So the maximum function is going to work out, well, which one's bigger, -3 or 1,000. It's hopefully going to return 1,000 and we're storing it in this max2 variable. So our max2 variable should now have 1,000 in it. And then we're going to print out the maximum of -3 and 1,000 is 1,000 because we're printing this max2 variable. Okay, is everyone happy with that, sort of? Yep.
I have a question. So earlier this happens as soon as you put the sort of when you put function in the print statement. This happens as soon as you are like it's coding the print statement, right?
So the question is, so right now how I've got it, I've done the maximum on this sort of separate line and put it in a variable, then I'm printing the variable. We could do exactly the same thing by putting this in here. Now, what actually happens before this printf runs, or before any function runs, C will go and make sure it can evaluate all of these different inputs. It'll work out that N1 is actually whatever N1 was. Imagine I typed in -3. It'll go and work out that N1's -3. It's going to work out that N2 is 1,000. Then it's going to go and execute this function and get the return value. Yep?
And then my actual question was, is there like a scenario where it's too slow?
Oh, is there a scenario that's too slow in this case? I'll get back to that in 1 second. In this case, instead of storing it in a variable and printing that variable, we can just plug in this whole function. It'll go and execute and give us back an integer, and then printf can print that integer out. But you can do it whichever way is easier for you to begin with. Now, if we were really worrying about efficiency, if this was a really difficult function that took a long time to run and that we needed this value many times, we might not want to keep calling that function. But I don't think we need to worry about that at this point. Just whichever way makes more sense to you, you could do. Yep.
Are you also saying that you can put the value of a variable into the variable slot instead? Like, can you replace N1 with its hard-coded value 7, technically?
Yeah, you can put hard-coded values in when you're calling the function, like here. Or you could put variables in. Is that what you mean?
No, I mean like in the printf.
Yeah, you could if you wanted to in printf. Just do that. Yeah,
That would work.
that would work. But you'd probably, usually you would just put it in here, right? Okay. But yeah, you can try all these things. But as long as whatever's in here is of the right type, which is integer, we've got integer variable, and then a function that returns an integer. And we call that an integer function, a function of type int. It can be put in the place of any int. Yep?
Okay, so 4 functions, right? I mean, technically you could copy the function over and over, but it would be not very effective, right?
So can you just say that again?
Okay. So is there like a reason why we should use function over copying the function over and the code over and over other than style?
Is there a reason we should use a function rather than copying the code? So instead of doing maximum, I could just have in my code up here this kind of code that works it out, and then down here again this kind of code that works it out. Yeah, I don't think C is going to care if you do that, but it becomes error prone because then you're copying and pasting and forgetting to change things. So when we use functions, it's to make our code more manageable. It's so we can wrap this thing up, and when we look at it, if I see this line that says maximum 10 and some number, I know straight away, oh, we're finding the maximum of these two numbers. If instead I'm looking at this, my brain has to work harder to see what's going on. It's looking at the low-level details. So by putting these things in functions, it's providing humans with that abstraction to not focus on those minute details of that if statement and just think of the larger thing, which is this is finding the maximum. And it stops us copying and pasting things and creating bugs and having really long code. Yeah. All right. Did you have a question? Oh, down. Thank you. People are trying to tell me that you've got your hand up. Yep.
Is it standard protocol to put functions after your main?
Now, this is a very good question. Is it standard to put the function after the main? In our course, in our style guide, it tells us this is how we want you to do it. So imagine you're reading some code. You want to have this sort of high level view first. You want to see the main, and just by looking at this main, you can think, well, this finds the maximum of two numbers, prints it out, finds the maximum of these, and prints it out. And you may not have to look any further. If the first thing you see is this maximum function, it doesn't really tell you anything about the program. So we like to have the main at the top to give you the overview. And then if you think, oh, well, I wonder how that maximum code works or what it looks like, you can go and dig deeper. And this is why we've got this prototype at the top. So if you forget this prototype and you try and compile it, you'll get this error, and you might have seen a similar error before. It says, warning, implicit declaration of function maximum is invalid, C99. It looks very scary. But what it's saying is the compiler, which runs from top to bottom, has gotten to here, and you've got this maximum, and it doesn't know what you're talking about. Like, it's thinking you're making up this maximum function. It doesn't exist because it's doing it from top to bottom. Now, if we did, this would be a solution to think, well, I'm not going to do a prototype. I'm just going to move the whole function to the top. And that does solve the problem because C knows, oh yeah, there is a function called maximum. So when it gets to here, it's not confused. It goes, yep, I've seen this function. That function's fine. So this is a way you could do it and it would work. But like you mentioned, we want you in this course to put them at the bottom for style reasons. If you put them at the bottom, then you have to have this prototype for it to compile. Okay? So if that didn't make a whole lot of sense, just lay it out like this for now. Put the prototypes at the top, then the main, then the functions. Yep, question?
So can functions only be like integers, or can they be other things as well?
No, so that's a great question. Here we had inputs which are integers and a return type that's integer. Let's do something where that's not the case. So let's try and write, how would I write a function, or what would the prototype be if I wanted to write a function that prints a square of a given size? So I say 4 and it goes and prints 4 by 4, lot of stars. I say 10, it does 10. What would the prototype be? So first of all, we'd give it a name, like maybe print square. We don't just want to call it F1, F2, F3. People do that. Or something random like tomato or something. What would the input be? Yeah, so in this case, yeah, we do have another int. It'd be like the size. But what is the return type? Yep. Well, the thing is with this one, that the answer was character. Now, the character, is the character going back into the program to use? Where's the character going? So, like, these are characters. Where are these characters going if we're printing it out? To the terminal. So these are going to the terminal. Is anything going back in the code to reuse? Are we going to use these in our code? We're not really. This is a tricky type. It's called void. So what this means is, actually I've got a slide about what this means. Our function doesn't actually need to return any values. It's doing something. It's printing stuff out on the terminal, but it's not giving back any kind of answer or any kind of data that we're going to use in our program. So it's like when I said, give me the maximum of 5 and 2, the maximum function gives me back an answer of 5, and I can go use that in my program. But if there was a print square function sitting there and I said, go and draw a square, they would just go draw the square. They don't give me back any answer as such. They just go do something. So this is the kind of function you have. We sometimes call them procedures. This is where, oops, it's not really answering a question or giving us back a calculation or something. It's just doing something. It's following orders, but it's not giving us back any answer or any data that we're going to use in the rest of our program. Does that kind of make sense? It's like I say, you go print a square. You don't have to tell me any answer. But if I say, what is the maximum of 5 and 2, you need to give me an answer. So this is something you'll see a lot, this keyword void. And it kind of means like nothing. So there's no return type here. So what does this look like? I'll bring up the code. What does this look like in our function when we put it together with a whole program? So I've got my prototype up the top. I've got an input and a void return type. I've got my function down here. Now don't worry about the exact code in this function. It's doing some kind of while loop. It's given a size. So that's how, it knows where to go to in the while loops. It uses that size variable to make sure it's the right size. But it's just doing a while loop. Now you'll notice that there's no return statement. So over here, we calculated something and we had to put return. And this thing that we're returning, it has to match the type. So if this says it's returning an int, this thing we're returning has to be an int. In this example, we're not returning anything. There's no return statement. It's just doing something and it's printing stuff out on the screen. You can put a return statement in here like that that's empty. But our function will finish anyway when it gets to the end. We wouldn't need it in this situation. But with something that's meant to return something, you have to have that. Otherwise, the compiler would complain. Now, when we're calling this function here, we're passing in the size like we've sort of seen before. But this is void, so we can't have anything saying something is equal to this because it's not returning anything. Okay, does that make sense? So if we do this and we compile it, and often people are really confused about these void types. Size of the square, yay, size of the square, etc. Any questions before I move on?
Instead of having the return 0, why can't we declare the main function as well?
Oh, somebody just asked a very good question. Because remember, let's have a look. We've got this main function that we've been writing this whole time, and we've always called it int main void. Well, void means nothing. So it gets no input. We're not given input to our program before it started running. So we've got a void there, the way we do it. But we're returning an int. So this is why we've always got that return 0 at the end. Now, the reason why we do that return 0, it doesn't really make any difference if we're just running our own standalone program the way we're doing it. But we could be connecting programs to other programs. And those other programs might want to know what that return value was in certain situations. So you'll see that as you go further, that these return values can be useful. In this course, they're not really going to be useful, but we're just going to do it. Yeah, I hope that makes sort of some sense. This means it executed properly. You could have if conditions and return some error code, and then some other program that you're cooperating with could get that code. All right. All right, so here's another one. Just so you see all these sort of different examples. This one here has void input. So this function doesn't need input. It doesn't return anything. It just does something. So every time we run this, it's just printing out, warning, don't plagiarize. We do have an assignment coming out next week on Tuesday night, so I'm trying to send you these subliminal, well, not so subliminal messages. When we use one of these functions that has void input, we just use brackets with nothing in it. This is our function call. It's like we don't have to give this any information. It's just going to go and do something. It doesn't need to give us any information either. Void input, void output. It just does something. And it saves us from rewriting this code again and again and again by having it. Question?
Yeah, would you only use the void function for like something you want to print out?
The question was, would we only use it for something we want to print out, a void function? In this course, I would say yes. There might be other things in more advanced scenarios where you might, I don't know, be connecting to the internet or something, but not returning information back to the main, or there might be other things that you might be doing as side effects, generating a file that gets downloaded or something. But for us, it would probably be printing stuff that would be void. Okay, so this is just a recap of what parameters are. We've spoken about this. I've gone through the execution flow. We've talked about prototypes. One thing I didn't talk about is the function comments. So when you write a function, you need to have a comment placed before the implementation, describing like the purpose of the function and any side effects the function has. Well, a side effect in terms of what we know how to do would be printing something. So you might say, let's have a look. My comments probably aren't that great because these are fairly simple functions, but this says this function returns the maximum of the given values x and y. This is telling us that, all right, it doesn't return any value, but it's printing something out, right? So if somebody was going to use this, they know, well, this is going to print something on the screen. I mean, it should be obvious from the name, but you want to know if you're about to use something that's going to print something on the screen versus just do a calculation. Okay. Or, you know, connect to your bank account and, you know, you want those sorts of things in a comment. All right, yeah, choose meaningful names, not F1, F2, F3, F4, you know. So we'll just do another couple of examples. We'll do some code examples where we will see other types. So everything's been ints or voids. Let's do the area of a triangle. And most likely, you might think, why do we need it in this example? But we're just trying to do a very small example here, so it's not too confusing. So I've got a base and a height and an area. I've got all of those variables set up. It's going to say, please enter the base and height. And then it's going to let me enter the base and the height. Oh yeah, I haven't written the program. Why am I compiling it? Now, before you start worrying, if you think my maths is stale, I wouldn't have known that formula for the area of a triangle. Oh no, do I have to go and learn all those area formulas that I used to know in year 10? No, if we would always give you any formula, and it wouldn't be a difficult one, you know. We're not going to expect you to know all these maths formulas. It's just that this makes a good example and we give you the formula. Okay, so first of all, let's do it without a function. Ideally, you'll get to the point where before you start coding, you'll think about the problem and you'll think, okay, I might break it down into these functions and you might plan ahead. If you're just starting out, you mightn't be able to do that yet. And even when you can do it, you might not, when you're thinking ahead and planning, you might not realize, actually, maybe I should have done that as a function. So sometimes you'll just end up writing the code, then you'll want to turn it into a function. That's what we're going to do now. So how do I just write this as code? I'm trying to find the area, and I've been told by the very kind people that the formula is half times b, which is base, times height. So I plug that in and then I can print it out. Now, can anyone see any problems with this? Oh, I've just randomly typed an S, so that's a problem. Let's make it a bit bigger. Let's try again. It compiles. All right. Area of the triangle, if I put in 2 and 4, what should it give me back? Okay. So what have I done wrong? Nothing to do with functions. Why am I getting 0? I've done 1 divided by 2. The oldest sort of gotcha in the book. I've without thinking just typed in 1 and 2 into my computer, 1 over 2 into my computer. So remember, this will do integer division and we'll get 0 anytime we type in 1 over 2. What could I type instead? I could just type in 0.5, right? Other options could be 1 over 2.0 or 1.0 over 2.0 or whatever. But in this situation, yeah, 0.5 seems the most reasonable. So yeah, you'll get that, you'll accidentally do that many times. Even when you really know about it, you'll still accidentally do it. And we should always know what answer we're wanting to get when we're testing something. Otherwise, we don't know if it's wrong. What are we trying to get? What answer should we get? Okay, good. Now, in real life, you'd test it more thoroughly, but that will do for now. Now, I want to create a function that can do this area for me. Because look, that looks like one line of easy code, but we already saw that I made a mistake. I don't want to write this code again and make it the same mistake again. I want to put it in a function. I'll call it, what will I call it? Yeah, something like triangle or triangle area, area triangle. And we want to, we don't really have to spell triangle correctly, I guess. Now, what's our input into triangle, this function? We've got 2 inputs. They're doubles, and we can call them whatever we like. We could call them base, height, BH, whatever we think is the best style. Oh, okay, and what's the return type? A double, yeah. I give it base and height, which are doubles. It's giving me the area, which is a double. So this would be my prototype. And then down here, I would actually implement it. And basically, I would be saying, now I could do it in one line, but I'll do it like this. Area equals, I'm just going to go cut and paste this actually. That should work. What else do I need to do? I've got to do return. When I call the function, I'm just putting in the base and the height. It's doing the calculation, which I admit isn't a huge calculation, right? It's a one-liner. And it's returning the answer, and I'm printing it out. Is this going to work? I don't know what to enter. 2 and 4 again. Yay. So here look, this is a very small example, but this is how we can turn something into a function. And just be aware that it doesn't matter what these variables are called. These variables don't have to match. If we called our variables in the main B and H or anything else, this is still all going to work. They don't have to be called the same thing as a function name. That's not going to work. Because, you know, in a big program, you might be using this function again and again with different variables. So these variable names don't have to match. Okay? It's just going to pass in whatever values in those variables. But now I've left this with bad style because B, H, and A aren't great names. Anyway. Any questions about that? Yep. How would what?
For the Pokemon example that you used to lead it, how would you make this?
Now this is a great question because that's exactly what we're going to do now. So I've got all this code. I'm going to copy and paste it because I want to leave this code so we can compare it when we're done. Right, this is our code. Now the first thing I would think of is, can we write a function that can print out one of these Pokemon types? That would really improve our code. So this is enum Pokemon type. I'm going to write something called print Pokemon type. What's my input? I want code that can print one of these things, right? So if I'm given a Pokemon type, I want to be able to print it out. So here, I'm, checking my type, and if it's equal to fire, I print out the word fire. So if it's fire, I want to print out the word fire, etc. The thing I'm trying to print out is of type enum Pokemon type. Right? This is the type that I'm dealing with. Right? So instead of it being int or double or something, this is our basically custom type. We made a type called enum Pokemon type. We can set it to have these values, but now we want to be able to print out these values nicely without it just being 0, 1, 2, 3, 4. What would the return type be? Yeah, void. It's just printing stuff. It's not needing to tell us anything. It just needs to go and print it. So the way it's going to work is we pass in a type and it prints it out. So let's implement it down here. Now, that will take me a long time to type in because I'm slow, especially in this scenario where we've got people watching. But basically, this is the logic of what I want to do. So I'm going to copy it into here. Now this is what happens a lot if you weren't planning to write a function and you've already written it in your code and you see that you've kind of got the same code everywhere and it's a mess and you want to clean it up. You'll move it into here, but then, the variable names won't be exactly the same. So here we were talking about Jigglypuff's primary type. This function just has to work for any type. Any type, not just Jigglypuff's primary type. So we need to use the variable name that we've got here, which is type. Now, VS Code makes it easy. If I just highlight the thing I want to change, and I can just do Control D to select all the ones under it, and then I can just change it, and it changes them all at once. So now I've changed it. I've got if type equals fire, print fire, else if type equals water, print water, etc. That's my print Pokemon type. Now up here, I can get rid of all of this. And instead of having this if statement, I just go and say, please print the Pokemon type for Jigglypuff. Jigglypuff. Well, this gives me the whole struct for Jigglypuff. I need to I think I've lost my struct over here. I didn't copy my struct over. Yeah, Jigglypuff is a whole struct Pokemon. I want to print out here the primary type. So I'm going to say take Jigglypuff's primary type and go print that out for me. Then I'm going to say now take Jigglypuff's secondary type and print that out for me. So instead of having all of that stuff that we had, my main function is just going to look like this, right? Before, my main function looked like this, went down to line like 86, now it's going down to like 41. And it's a lot easier to read. Now, if you're not on top of every single line of code that I wrote, well, you couldn't be because I was copying and pasting stuff. But the idea is to see the difference it makes when we can start using functions. And it saves us time as well. So this should do the same thing. Oh. And it means also you write the function once and you can check that it works and you don't have, the chance of every time you rewrite it and copy and paste it making mistakes. All right, is everybody happy about the prototype for this? We can enums now are a type. We can pass them in to functions. I'll do one more thing before we go. We can also have a function to just print out all the Pokemon details. So this is going to take a whole struct Pokemon. Right? So this takes the whole struct. This one just does an enum. Okay. Because in this example, we've only got one Pokemon, but in a real example, you might have lots of Pokemons. So you don't even want to be copying and pasting this and changing it all the time. So we want to move that into a function as well. So let's do that. In here, it's just going to print out the Pokemon stats. Again, this isn't just for Jigglypuff. This is for any Pokemon that we get, and our variable is called myPokemon. So I'm going to change all of these so they match the variable in my function. So now I can pass in any struct Pokemon and it'll go and print out all of the details, right? And we can see that this function is doing a function call to our other function. So I've got the main function. It's going to call print Pokemon. It's going to pass in Jigglypuff, which is a whole struct. And this function is going to print out all the details. And to do so, it's going to pass in its primary type and its secondary type into this function. So this is now quite complicated. So if you're feeling a bit lost, the main point is we can pass in enums into our functions, we can pass in structs, and hopefully you can see that this makes our program much easier to read. We have, okay, I've got this Pokemon and now I'm going to print out its details versus all of this, right? Oops. It should still work though, right? Once you've changed it, you want to check that it still works. I think it does. Okay. Okay, so hopefully that example wasn't too confusing. It's really to show you the benefit of functions, because the simple examples that we did that were maybe easier to understand didn't really show you the benefit. So don't worry if that was a bit confusing, as long as you can see, yep, that looks better. Right, I think I better leave it there. So yeah, tomorrow we will talk about style, and we'll do a little bit more with functions as well. Thanks so much, everybody. Thanks for all your questions as well.